Go through a review of just area formulas, and just going to start with the rectangle. Remember, we've done these in class, but I just want to point out in a rectangle you have, oops, not that. You always have a square angle, and the square angle becomes important in all of the area problems. So in other words, when you look at a rectangle, you have a base, and then you have the height, and the base and the height make a square angle. Because of that, your rectangle can be divided up into little squares, and we kind of estimate here. Looks like we can divide this up pretty evenly. Into squares like this, because there's 3 units on the side, so I divide the side into 3 units. There's 6 units along the base. So when we multiply the base times the height, the base is 6 units, and in this case the units are centimeters. The height is 3 units. When we multiply those numbers, we get 18. And if you count the squares inside, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 18 squares inside. So we say the area of this rectangle is 18 centimeters squared. Or you could also write it as 18 and write centimeters, I'll use the abbreviation, squared. So that's the beginning review problem. To find the area of a rectangle, you do base times height. And the thing is, when we look at parallelograms, the same formula works as long as you know that the height and the base have to form this square angle. So let's scroll down to this next picture. In this picture, we have a parallelogram. So the square angle that we look for is right here. So if you think about it, some people, when they first learn area of a parallelogram, they talk about changing the parallelogram a little bit and taking, say, this triangle area and chopping it off that side and sliding it in this side. And then it's not over here anymore. And they first learned parallelogram area by thinking about rectangle area. So if I take that side off and put it to the right, I end up with a rectangle. And my rectangle, if I look at for the base of my rectangle, it's this distance here, which was the same distance here. And then I look for the height, and it's this distance right here, because it makes the square angle. So we don't really need to chop this up. It helps us think about it. But if we go back to the original shape and look just at the parallelogram, this base is the distance 4 units. So the height is the line or the segment that makes the square angle with the base. In other words, the height is how far apart the bases are. So in this case, the height is also 4 units. So to find the area of this parallelogram, we never use the 4.5 for the area. We just use the base, which is 4, and the height, which is 4. And so the area of this parallelogram is 16 centimeters squared. So even though when you first learn area, we talk about cutting shapes up, after a while, we really want you to focus on being able to use the formula. So if I drew a new parallelogram, and I said that this distance was 13 feet, and this distance was about 25 feet, and then I said that this distance right here was, say, 10 feet. What we're really looking for is where is that square angle. The square angle is right here. The square angle between the base and the height. So sometimes you'll see it, the base with the height inside the figure, but sometimes you'll see the height drawn outside the figure. And you have to be flexible. Sometimes the height will be out here, and it won't touch the base, but it will be lined up with the base. So you have to look at all the numbers in your picture and decide which ones you need to use. So for area, you just need to use the base, which is that this distance right here, 25, also the same down here. So the base is 25 and the height is 10. So our area is 250. And in this case, our units are feet, so we say feet squared. So that's the area of this parallelogram. Even though the focus of this video is not perimeter, some of you might be wondering when you use the 13. Well, the 13 we use when we're looking for perimeter, because for perimeter, we're going to go around the whole shape. We're going to add 13 to 25 to 13 to 25. So you use that slanted side when you're doing perimeter. So we really end up adding all 4 sides up for perimeter. So when we do that, we get 76. And since it's not square units, because it's not how much fits inside, it's like how much string you could wrap around something, we just say 76 feet. That's the perimeter. Okay, so the next thing we're going to look at is area of triangles. So you see the formula, area of triangles is base times height divided by 2. So let's just talk a little bit about why we divide the base and the height after we multiply, and why we divide by 2. So I want you to visualize this triangle here, and if I make a copy of it and rotate it, I could piece it together with the original triangle and make a rectangle. So we just talked about finding area of a rectangle, and that's base times height. So if I wanted the area of this whole rectangle, I would do the base, and then I would multiply it by the height. But remember, I only want the area of that triangle, which is exactly half the rectangle. So I have to take my rectangle area and divide it by 2. Divide it into 2 equal parts. So this is 12 divided by 2. So my area here is 6 centimeters squared. So you might be wondering if that works for every kind of triangle. This first triangle is a right triangle. And the square angle that we were talking about is where the two sides meet. But on a lot of triangles, the two sides don't meet at a square angle. So if we look at this triangle, we make a copy of it and spin it around. When I piece it together, I get a parallelogram. So remember, the area of a parallelogram was still base times height. But in this picture here, we find the base. It's 4 units. And if we look for the height, we're looking for where that square angle is. So that's right here. And the height is this distance right here. So if I remove this, because we only want half of the parallelogram, if I remove that, we can see that the height is 4 centimeters. But I don't want the parallelogram, so I'm going to divide it into half. So this is 16 divided by 2, which is 8. So the area of this triangle is 8 centimeters squared. So base times height divided by 2. That's the area of a triangle. Let's look at one last example. Even a triangle with an obtuse angle, which is an angle that's bigger than 90 degrees, has a base and a height. And in an obtuse triangle, the base and the height, they don't touch. But remember that the height only has to be in line with the base. It doesn't have to touch the base. It just has to be in line with the base. It needs to have a square angle that's in line with the base. So in this problem, the area of the triangle is the base of 3 times the height of 5. Whoops. Height of 5 divided by 2. So this is 15 divided by 2, which is 7.5 centimeters squared. So that's the area of triangles. That's how you do the area of triangles. So if we just briefly look back at the two things that we've talked about areas of rectangles and parallelograms. And since every triangle can be doubled to make a parallelogram, the formula is related. So the area of a triangle is like a parallelogram, base times height, but because it's only half of a parallelogram, we divide by 2. So I'm going to throw in a third shape here, area of trapezoids. So a trapezoid, let me make a picture of a trapezoid. I'm going to pause it and put a picture of a trapezoid in. Here's a trapezoid. A trapezoid has 2 bases, and they're parallel. So here's the first base, and here's the second base. That's what makes something a trapezoid. There's only one pair of parallel sides, and it's a quadrilateral. If I copy this trapezoid, and I rotate it, oops, can you copy it? Let's try that again. And I rotate it, I can piece that trapezoid together with the original to make a parallelogram. So if you look at my new shape is a parallelogram. And the height of that parallelogram would be right there. It would make a square angle with the base. So if I look at the original trapezoid, for a minute, I'll take that original trapezoid out. I can catch it. And rotate it. We're trying to figure out the area of this. So in math books, you'll see this as base 1, and this is base 2, and then the height I'll use an H4. Remember, it has to make that square angle. The area of the trapezoid is base 1 plus base 2 times the height divided by 2. Sometimes you'll see it written like this: base 1 plus base 2 times the height and a fraction part, which also means divide by 2. So let's think about why that is. Let's imagine that this is 8 units and this is 12 units, and the height is 6 units. If we look at the picture above, this distance is the same as this distance. It's 12 units. So that must mean that this is 12 units. Similarly, this distance here is 8 units, which is also the same as this distance here, 8 units. And it's the same as this distance here. So if you think of this top shape as a parallelogram, it's just a parallelogram where the whole base is 20 and the height is 6. So the area of this parallelogram is 8 plus 12 times 6, or 20 times 6. But the and that equals 120 squared units. But the trapezoid is half of that, so we take that 20 squared units, and since it's a trapezoid, we divide it by 2. The area of the trapezoid is 10 squared units. Let's practice a problem. I draw a trapezoid here and say that this is 10 units here, say feet, and this is 8 here, and the height, which makes a square angle, is about 4. If we use the formula for a trapezoid, area is base 1 plus base 2, so add the bases, times by the height, and then divide your whole answer by 2. We would get base 1 is 8, plus base 2 is 10, times by the height, which is 4, divide your answer by 2. So keeping that going, 18 is 8 plus 10 times 4 divided by 2. From there, you could reduce fractions. So 2 divides it into itself once, divides into 4 twice, and multiplies. So that's 18 times 2, which is 36. And we have square feet. The other way you could go is, for the 6th graders, for the kids that are a little less comfortable with fractions, you can multiply 18 times 4, which is 72, and then divide your answer by 2. And you are still going to get 36 square feet. So this is the area formula for a trapezoid. Man, oops, I'm like 29 seconds over. Hopefully that will help you learn those formulas. And we'll be working with those all of next week.